So here we're going to look at section 2.3, and here we're going to look at lines. We're going to look at straight lines, that is. Now, with lines, there's this concept of the slope. And really, you do need to understand what the slope of a line is to really understand a line. In fact, it turns out, if you know the slope of a line and any point on that line, you can get an equation of that line. In other words, you can find an equation in X and Y whose graph is the given line. And we will actually see the point slope formula for an equation of a line. A line, again, is the graph of a certain equation in X and Y. We can write that equation in point slope form. That is, we can get its point slope formula. And you have probably seen the slope intercept formula of an equation of a line. That's that y equals mx plus b. I think that's what they teach in high school, the point slope form or point slope formula. That's actually a little bit more general than the slope intercept formula. It's actually, personally, I think it's a little more convenient than the slope intercept form, but you can use either one you want. They're both correct, of course. But again, you do need to know the slope of a line. And that's what we're going to start with now. So we already know that if you take any 2 points in the plane, you can always connect them by a line, a straight line, that is. But again, to really understand lines, we need the concept of slope. Now, and this is what the definition is: the slope of a non-vertical line, okay? And if that passes through these 2 points, so P and Q are 2 points that are different from each other, and they're on the line. So P and Q are 2 points on the line. Then the slope of that line is this. It's change in y over corresponding change in x. Now, it's unfortunate because, because you do have to be careful with the order because we're subtracting. Unfortunately, subtracting is where with subtracting, that is, you have to be careful with order. The way I like to think of it, I think some people learn this thing called rise over run. You could use that if you want. What I like to do is this. The coordinates for the same point, they're on top of each other. So for instance, y2 and x2, right? They're both coordinates for the point Q, or one of the points, that is. So they're on top of each other in the formula. Same thing with the other x and other y, right? x1 and y1. They're coordinates for the other point, so they have to be on top of each other in the formula. That's just how I like to remember it. That's just me, though. Okay. If you do that rise over run, whatever that is, if you do that, again, if it's correct, I'm not going to mark it wrong, so nothing wrong with that. Okay. Now, also, I don't know if I said this, but we're assuming this line is not vertical. Okay? It turns out a vertical line, you can't define the slope. What actually happens in a vertical line is all the x coordinates are the same. So if you tried to use this slope formula, at least, you would end up dividing by 0, and that's a no-no. But any other line any line that's not vertical, you could find the slope. And the slope actually tells you a lot of very nice information. This I'll mention. You go more into it if you take calculus But the slope is actually what they call a rate of change, but we'll get to that shortly. First, I want to do some examples. So let's find the slope of the line that goes through each pair of points here. So let's take this pair first, 3, 7, and 5, 9. So if we want the slope of the line through those points, again, we subtract the y's, right, over the corresponding difference in x values. That's what the formula says. So I do 9 minus 7 over 5 minus 3. 9 minus 7, right? 5 and 9 come from the same point. So 9 and 5 are, 5 and 9's on top of 5. They're on top of each other. They're next to each other. 7 and 3 come from the same point, so they're on top of each other. And we get 2 over 2, which is 1. I think what would happen is if you mixed up the order of the numerator, you know, the y's or the x's, you would end up with a negative. You would end up negating this. You don't want to do that. That's for the first pair. So for the first pair of points, we get 2 over 2, which is 1. So the slope there is 1. For the second pair here, right? 1, 6 and negative 4, 3. Same idea, right? We just want to get the slope, so we subtract the y's, right, over the corresponding difference in x's. So we have 3 minus 6, and then we want to subtract the x coordinates from each other. And now negative 4 and 3 come from the same point, right? So we want them on top of each other, right? They are coordinates for the same point. Negative 6 and 1, and negative 6 and 1, right? Actually, no, what am I saying? 6 and 1, I'm sorry. They are coordinates for the same point, so they're on top of each other. 3 minus 6, which is negative 3. Negative 4 minus 1 is negative 5, so we get 3 over 5. There actually is a way to tell if a slope is positive or negative before doing such a calculation, but we'll get to that later on. Are there any questions about this, though? I mean, I can't see the chat, so if you have a question, speak it to your mic or use that hand raise feature. Otherwise, I'll just keep going. Okay. The slope is actually called the rate of change. I mean, we will see this later on when we get to the equations. It turns out, though, if you were to increase the x by 1 unit for a line that's not vertical, the y value, the y variable, that's going to change by m units. Again, m is the slope. M is the slope. So if you were to increase x by 1 unit, okay, what's going to happen is the y variable, that's going to change by m units. You know, it may go up or down. M is the slope, okay? That's what's going to happen. And again, we'll see this a little more later. Now, here is another example. Basically, we have these lines here, and we have these 3 points. If you were to calculate the slope of the line through these points, you know, 1, 2, and 2, 4, you would actually get, you know, change in y, corresponding change in x, right? You want 4 over 2 on top of each other. 2 over 1, 2 and 1 you want on top of each other, as you can see. You have 4 minus 2 over 2 minus 1. Here you get 2. Okay, so this is the slope, 2. And let me just say this, but notice, oh, no, let me not say that because that might cause more confusion. Here, they both start at 1, 2, but this line passes through 2, 6 instead. So it's the blue line here, as you can see, okay? And the slope of that line is 4, okay? So notice that both of the lines have a positive slope. Actually, you know what? No, I don't want to rush this, so let me stop here. It's actually 150. This slide will pick up from next time. That's actually good because this is where I got up to in the other class. So let me stop this.